All right, guys, let's go ahead and do hyperbolas. Yesterday we did ellipses day 2, and so hyperbolas and ellipses are kind of along the same lines. If you kind of look at them, they don't look anything alike, but really what a hyperbola is it's an ellipse kind of flipped on itself. So the equations are very similar. Here are the equations, horizontal and vertical. Be sure that you get all the x's and the y's and all that stuff correct. The one thing is that the difference between ellipses and hyperbolas is that an ellipse has a plus symbol here, and for hyperbolas it has a minus symbol. And the only other difference is that whatever comes first, x or y, that determines which one's horizontal or vertical. So if the x is first, then it's got to be horizontal. It doesn't matter what a and b is. A could be 1,000 and 10 million, and it's still horizontal. And same thing for vertical. If the y is first, it doesn't matter what a squared and b squared are. If whatever's first, that's the way it's going. So let's go ahead and take a look at an example. We're going to look at this one, which is in your little foldable. The shape of this picture is kind of weird. We first kind of have this imaginary box right here, and that just kind of helps us graph it. And so we'll kind of talk more in depth about that in a second. And then you have these diagonal lines that are here and here. Those diagonal lines are called asymptotes. The graph can get really close to it, but can't quite touch it. And that tells us how wide to make the picture. The first thing is, where is the center? Well, the center of our graph is right there. Now here are axes, so it's going to be at 2 comma negative 3. So let me zoom out just a wee bit. So our center is at 2 comma negative 3. Before we get to the equation, let's talk about our vertices. Vertices are where our graph actually is, so there and there. Looks like our graph is at 6 comma negative 3 and at negative 2 comma negative 3. Please pay attention to the fact that our x value changed, our y value did not change at all. Oops, I wrote that in the wrong spot. My bad. But yeah, anyway, so that moved and our x value changed and not our y. It's going to be kind of the same way, but the opposite there with our minor vertices or co-vertices. That is this point and this point right here. So that point is at, looks like that is at 2, 0, yeah, 2, 0, and at 2, negative 6. Yeah, we're going from the center down. So here's the center, and then that is 3 units down, so that's at 2, negative 6. 2 units, or 3 units up is at 2 comma 0. I think we're ready to go ahead and graph now, or write the equation. Since it's horizontal, that means x goes first, so x minus 2 squared. And then the distance from my center out is 4 units, so 4 squared is 16. And then it's a minus symbol, that's just what hyperbolas have. And then y, and then it's opposite, so plus 3 squared over, and then my distance from my y is 3, so 3 squared is 9, and then always equals 1. Got a couple things, and then we're almost done. My foci, it's a very similar relationship with ellipses, except that it's, in this case, it's a squared plus b squared. So ellipses have a minus sign here, but a plus sign for the equation. Hyperbolas have a minus sign for the equation and a plus sign for the relationship of the foci. So we're just going to add 16 and 9 together. That gives us 25. Take the square root of 25, that's 5. So my foci, unlike ellipses, ellipses have the foci on the inside. Hyperbolas have the foci on the outside. So we're going to still add to our x value because that's our center. Foci are with the major vertices. So I'm going to add 5 units to my x value. So 5 plus 2 is 7, comma negative 3. And then I'm going to also subtract 5. So negative 3, negative 3. The last thing is we're trying to find the slope of these asymptotes. Well, the slope is just the y value. So up however many the y value is. So in this case, it's up 3 from the center. So up 3, and then from there, it's over 4. We're just finding the slope of this line right here. Think back to your Algebra 1, rise over run. So my slope is 3/4. And then conversely, my other one is going to be down 3 and over 4, finding this asymptote now. So the slope is going to be negative 3/4. Go ahead and pause it, and I want you to go ahead and do the vertical one, and then I'm going to show you the answer. Okay, here's your chance to pause it. Go into the answer. It's a very ugly picture, but there are the answers. Let's see if I can get you the answers real close there. So our center is at 0, comma, -3. Our equation is y plus 3 squared over 25 minus x squared over 9 equals 1. Our major vertices are 0, comma, -8, 0, comma, 2. That's because we're going up and down 5 from there. Or y is first, by the way, because it's vertical. Our minor vertices are 3, -3, and -3, -3 because we're going 3 left and right with the x values, so the x is changing. And then my c, a little awkward, it's 5.8, so we're adding and subtracting 5.8 to the y value. Slope is 5/3 and -5/3. Good luck. See you tomorrow. Bye.